Good evening. I am Professor Shalini Sahay from EC Department SIRT. Today in this lecture, I will discuss the practical for the magnitude response of the band stop filter. First, it is the aim which to plot the magnitude response of a band stop or reject filter. So a band stop or reject filter is a filter which will reject a particular band and it will allow the other frequencies. Now in this graph I have shown, so this is the band stop filter where the stop frequency lies between the FH, the higher cutoff, and the FL between the lower cutoff, and 0 to FL there will be the pass band, and above higher cutoff there will be the pass band. So stop band will lie between the boundaries of two pass bands. Now the band stop filter is formed by a combination of low pass and high pass filter with a parallel connection instead of cascading connection. So in band pass filter we will connect the low pass and high pass in series, whereas in the band stop filter they are low pass and high pass are connected in parallel connection. So the name itself indicates that it will stop a particular band of frequency. So it eliminates the frequencies which is called as band elimination filter or band reject filter. It will also possess two boundary frequency, or rather the two cutoff frequencies, lower cutoff and the higher cutoff. Here the filter moves from pass band to the stop band, and for higher cutoff range frequency the filter moves from the stop band to the pass band. Now, in between these two frequencies is the attenuation band, which means that the filter will stop the input voltage or to pass through for the particular certain range. Now here the FL represents the lower cutoff frequency and FH represent the higher cutoff frequency. Now the center frequency, it is the sum under root of lower cutoff and higher cutoff. So when the input signal is given, the low frequencies are passed through the low pass filter in the band stop circuit, and the high frequency are passed through the high pass filter in the circuit. This is the block diagram where the low pass filter and high pass filters are connected in shunt. So the low pass frequency will pass through low pass filter and the high frequency will pass through the high pass filter, and will take the output voltage from the shunt combination of the low pass and high pass filters. In practical, due to this capacitor switching mechanism in the high pass and low pass filter, the output characteristics are not same as that of the ideal filter. As we know that the charging and discharging of the capacitor is exponential. So when the filter moves from the pass band to stop band, the capacitor will discharge from the maximum value to the zero value, and when it moves from stop band to pass band, again the capacitor will have to charge from the lower value to the higher value. As its nature is exponential, so we did not get proper ideal characteristics of the filter. So there will be some a mixing of frequencies take place in both sides of the band. Now the band stop filter, which consists of R, L and C, we have made this band stop filter with the help of resistance, inductor and capacitor. Now the outputs is taken across the inductor and the capacitor, which are connected in series. Now we know that for different frequencies in the input, the circuit behaves either an open or short circuit. So at low frequency, the capacitor acts as an open circuit and inductor acts as a short circuit. So for the lower frequency, capacitor will become open and inductor will become short. So only the low frequency will pass through the circuit, and at high frequencies the inductor will behave like an open circuit and capacitor will behave like an short circuit. Now, thus at low frequency, the circuit acts as an opaque because the inductor and capacitor are connected in series. By this is also clear that at mid frequency, the circuit acts like a short circuit. Thus, the mid frequencies are not allowed to pass through the circuit. So, if it behave like in short circuit, so there will be zero voltage drop. So, when this circuit behave like in short circuit, there will be no output voltage. The mid-frequency range to which the filter acts as a short circuit depends on the values of lower and upper cutoff frequencies. This lower and upper cutoff frequency values depends on the component values. So these values can be calculated with the help of the lower end frequencies of the lower frequencies as well as the values of L and C are determined by the transfer function. We know that for designing the band stop filter, we'll take the transfer function, and we have written the transfer function with the help of the circuit diagram. And here we have taken omega is equals to 2 pi f. Now the MATLAB code for this band stop filter, we have taken the frequency range from 0 to 0.01 interval up to 500. We'll take the G as the gain of the band stop filter. We have provided the gain, and to plot the magnitude, gain versus frequency, we have taken one command, that is semilog x w, and absolute value of G has been taken. We make the grid on, so we'll give the title as magnitude response of the band stop filter. We have labeled the X as frequency and Y label as gain. So with this program, we'll plot the simulation result of the band stop filter. We have marked the title. These are the labels X and Y. We have taken the frequency on X axis, and on the Y axis we have taken the gain. So for this frequency, for this is the band for the lower cutoff frequency. So we will have the gain as it is the pass band. We will have the gain as 1. And for above the higher cutoff frequency, again we will have the pass band and the gain will be equal to 1. This is the attenuation band or the stop band, where the gain is reduced from 1 to 0, and from here it will rise to 0 to 1. So this curve comes due to the capacitor nature. So we did not get the proper ideal characteristics, rather the practical characteristics of the band stop filter. Thank you.